So today I'm going to show you how to, in Desmos, make a really good looking graph for your project. Please note that you do not have to do it in Desmos, though I strongly encourage it because it's really nice to do it in Desmos. This looks really complicated out the side, but do not let that fool you. And if you do it by hand, you really have to make it look nice and neat because if I can't read your roller coaster at all, then I can't grade it and I can't give you the points that you maybe deserved. So if you do it by hand, keep that in mind. But if you do it with Desmos, there is going to be a link in Schoology for you to submit a screenshot. I'll show you that in class. But I'm going to show you how to do this. Again, this is my example of a roller coaster. So let's get started. The very first thing you need to do is make sure you are signed in to Desmos. So make sure your name is right here. If it is not right here, then you need to push the login button, log in with Google, and then your name will appear here and you'll be good to go. The whole reason I'm having you do that is because if you do something in Desmos, then you can click the save button and save it. But if you're not logged in, Desmos will not save it for you at all. It will delete it, and that would really suck because if you didn't finish it or you didn't get a screenshot of it, there's no way to get the work back, and I don't want that happening to you. Okay, so make sure you're signed in. But you're like, wait, when I put it into Desmos, it's like all sorts of funky. Like I don't see a good graph. What's happening? So suppose that happens. Go to the little graph settings right here, the little whatever that's called, wrench, I don't know. And put in your like a realistic x-axis. So from -1, so we can see a little bit past 0 until, well, your roller coaster definitely needs to be at least 30 seconds long, but it could be longer, so maybe I put 40 for right now. Your y-axis is how low and how high. Maybe I don't go super far down. Like you can't go below -100, but that's a little too far down. So maybe -50, maybe -30. Okay, that's better. Kind of have to mess around with it until you get something you like. And then my roller coaster goes about 250 feet in the air, just about, okay? So now it looks like more like a roller coaster. Note that your function is still the same function. Nothing changed here. All you did was change the window. So now it looks a whole lot nicer. The next thing we're going to do is we're going to tell Desmos only show me this much of the graph. So we're going to do curly brackets, 0, because your roller coaster should only start at 0. We're going to open the keypad here and put the less than or equal to symbol, then X, less than or equal to, and wherever your roller coaster ends. After how many seconds does your roller coaster end? For me, it's 35 seconds. So that's why I put 35 here. That's only because of my roller coaster. If your roller coaster goes longer or it goes a little bit shorter, that's the number you're going to put here. Okay. So see how Desmos took off all the extra stuff? Because unfortunately, your roller coaster is not infinite. It will not keep going down and down and down forever. Okay. So we're already starting to see something that looks really nice and really like what we want. The next thing you need to do, and this is even in your rubric, that you need all your zeros marked. So the great thing about Desmos is that it already kind of knows that those are important points that you might need. So it already has points on them, but you need to go a step further than just accepting the gray dots. Instead, we're going to click on all of them and start clicking this book with an arrow on it and see how it popped it up here. You're going to do that for all of them. All your zeros. And if you miss one, try your best not to miss one because that's how you're going to get full points. If you miss one, it's an automatic 1. There is no in between. So it's either they're all correct and marked or they're not. Okay? So anytime you're your roller coaster touches the ground, aka the zeros, those need to be marked. Oh, but I really don't like how they're all different colors. So how we fix that is we're gonna put a comma in the first one, copy, delete, delete, paste, comma, copy, delete, delete, paste, comma, copy, delete, delete, paste. So now what it's doing is it just is putting all those coordinates on the same line. And now you see how they're all the same blue color. If for some reason you don't like the color, you can click on the gear here, and then you click on the color and you can change the color with what they have. You could even change it to a dotted line if you want, a dashed line, a solid line. You could change the thickness of the line and say 6, then 7. Oh no. Okay. I think what was it before? Standard, it's 2.5. So, yeah. Maybe instead of them being blue, I want them green. I want green points. Oh, maybe I don't want them to be dots. I want them to be stars. Oh, but the stars are so tiny. Maybe they need to be bigger. So maybe I put 12. There we go. Okay, now I like it. But we're not done just yet because we need the coordinates. So we're going to click this little check mark for the label, and you see how all of the coordinates showed up? There we go. And so even when I click out of it, the points don't disappear. But when you click on a point and then you click out of it, it disappears. This is a way to keep them on there permanently. Okay, well, now I need to do the same thing, but for all of the maximums. So take note of where they are, all of them. Again, if you miss one, you start losing points. So if you want all the points, you need to have all your relative maxima and minimum correct and marked correctly on the graph. And then I'll talk more about what this global thing is called. And then on your paper, you need to make sure you have a specific description of what these low points and high points mean for your roller coaster. Look at my example for what I mean by that. So if one's not showing up because it's already taken, because 16 0 is already a 0, click on the graph line and then it should give you the option. So again, I'm going to comma, copy, delete, delete, paste, comma, copy, delete, delete, paste. So now they, again, are all the same color, and I like red. Maybe I'll leave them as circles for now, and then label them. Notice how my 16 0 point is used for both the zeros and the maximum for one of them. That's okay. And that might happen. It might also not happen. It's really okay. It really doesn't do much. Just show me, just do this. Just show me that it double dips. It is both a 0 and it's a relative maximum. So, or a minimum. It doesn't, just show me it counts for both. Look at my example that I have here. Notice how I labeled that. I called this a global maxima. So the really cool thing about the minimas and the maximum, well, I guess it's not really that cool. Don't listen to me. But what it means by that is global is also absolute. Global is also absolute. And so where a local maximum is, or we use the word relative. That means the other points around it are kind of lower than it. So it's a high point relative to the points around it. So it's the top of a hill. Global or absolute maximums are the highest of high points. They are higher than all the other points on the graph, higher than all of them. And again, relative, here they're using local, but they mean the same thing. Relative minimums are relatively lower than all the other points around them. So they're relative. However, this graph here in this example, it doesn't have a global or absolute. Global and absolute mean the same thing. It doesn't have an absolute minimum because it's going to keep going down and down forever and ever and ever. There is no lowest of low y values, but it does have a highest of high y values. So that's why this graph, for example, has a global or absolute maximum, but does not have a global or absolute minimum. So in my graph, for example, if I were to, let me just illustrate this again. I'm going to copy and delete this. So my graph will go down and down and down and down and down forever and ever. But it will not keep going up and up and up forever. It does have a highest of high points, but it does not have a lowest of low points. It still has relative minimum because they're relatively lower than the points around them, but they're not the absolute lowest of low points. There is none because you can't even say negative infinity because infinity is not a number. So it has no absolute minimum, but it does have an absolute maximum, and I want to show that it does. So I'm going to copy, oh, let me put this back. I'm going to copy the point where it happens, which for me happens to be this point. I'm going to paste it in a different line, and I'm going to change it to be the same color. So I'm going to choose red. And I'm going to click label, but instead of leaving this blank, I'm going to type global maximum. So that way it's still a maximum, but it's the global or absolute. So it doesn't matter which one you write. Both of them are correct. Just show me that it is one of those. All the other ones, if you don't label them, I'm assuming that you mean that they are relatively minimum or maximum. So leave them as is. You don't have to word them that way, but you do need to on your graph show me which one's the absolute or global, maximum or minimum. But again, my graph doesn't have an absolute minimum because if I got rid of this, it goes down and down and down and down forever. Okay, so guys, we're already halfway there. So now we just need to do the same exact things, but for the minimums. And notice how I'm not including 0 or 35. That's because those are not minimums. Because again, think about if I got rid of this, it doesn't bounce, like it doesn't curve. It needs to curve and go from going down to up in order for it to be a minimum. So that's why I'm not including those. So now I have them and I want them labeled so I can see their points. You see how it's already shaping up to look a lot like what you're going to turn in? So we're good to go. We're almost there. The next thing we need to do, and this is also on your rubric, is you need to show me in different colors increasing and decreasing intervals. And on your paper, you need to write them in interval notation. So that interval notation is what you're used to doing. We've done that before, but on Desmos, it's a little bit different. So let's go back to our original function. And I really want you to notice how right here I have, and this is how we say it out loud, h of x equals. That's telling Desmos that h of x, anytime it sees h of x mentioned, it knows I'm talking about this polynomial only. So whatever you put here, you're going to have to put something here equals, kind of like this. You could do h of l, b of l, m of l. It doesn't matter. Desmos will know what you mean. Whatever you put there. And then we're going to do curly brackets. And we need to know from where to where. Again, let me use my handy dandy already made one. We go from left to right. So you see how my roller coaster is only going from the left to the right, and then it has to repeat. So we have to know when it's going up, going down, going up, going down, going up, going down. That's what we're doing, and that's how we're going to color it. So to color it in Desmos, you need to Again, like how we do it in interval notation, you only ever use the x values. So we would say from 0 is less than, not less than or equal to, because we never include the endpoints. X is less than or equal to 2.47514. Notice how I typed the whole thing out. If you leave out some numbers, it'll start shifting it and it won't be exact. So do not round. Instead, leave all the numbers that Desmos gives you there. So now do that for all the other ones. There we go. However, I don't like that they're all different colors. I do like purple though. So what I'm going to do is I'm going to click on the gear and I'm going to change. Ooh, wait, we've already used purple. Maybe I want blue. I like blue. So that's what I'm going to do. Blue. All right. So because we've only covered in increasing, whatever color is your polynomial, whatever color is here is going to be the color for your decreasing. So we don't even have to do decreasing because it's already colored for you because that's just how Desmos works. Oh, let me not delete everything. So you could be done here, I believe. I think that's all. Yeah, you could be done here. But if you want to be like super awesome, and put a roller coaster on it like how I did, here's how you do it. You need to go and Google something. For example, I did Steve in a minecart one time, and that, can I spell minecart? And like I found this good image and I really liked it. So you need to save the image on your computer. And then in Desmos, you go to the little plus sign up here and you're going to add an image and it's going to let you add your image. So, okay, boom, Steve has been added, but Steve looks ugly. So you need to do some finagling, flip him around to make him look better. All right. So the next thing, because right now Steve is just lost. He doesn't know where to go. He's not going to move. So to fix that, we need to put this exact thing in for our center. So that is, instead of 0 here, we're going to put C. And instead of the second 0, we're going to put H of C. The reason that it's an H is because that's the polynomial I chose, or the label for the polynomial. If you did L, you would do an L instead of an H. If you did a T, you would do a T instead of an H. I chose an H, so that's why there's an H. And then you're going to see this option to add a slider. Click it. And now you're going to see that Steve will move. But Steve moves very wonky. Steve goes off the graph and doesn't show up again, and he doesn't go all the way. So to fix that, click on this, and Steve is only going to be able to go from 0 to 35, at least for me, because that's only how long my roller coaster is, from 0 to 35. And then notice what happens when I push the play button. You see Steve go, and you've just done something really cool. And then you can play around with this arrow stuff and see what happens. But the big thing is that now you have Steve on a minecart, and you can even slide him around. Again, he's going up and down, up and down, up and down. And then you're going to take a screenshot of just your graph. You can keep fixing Steve if you want for him to look nice. And you can move him wherever you want on your graph if you decided to do a Steve on your roller coaster. It doesn't have to be Steve. It could be a roller coaster like in this one. I just did a classic picture of a roller coaster. Or you could do a skateboard, a bicycle, a motorcycle, a Hot Wheels car, whatever you want. You'll take a screenshot of this and put it in Schoology, and then that is your graph portion done. The rest of it is again in your rubric because you need to do more stuff than just give me a graph. But that's how you do something like this in Desmos.